This is a review of integration by parts. So in this example, we actually have x e to the x dx, trying to find the integral of that. So in order to find what this integral is, we're going to have to find what u and dv are, and we're going to take the derivative of u to find du, and the integral of v to find dv. So when choosing our u, we want to find something that can easily be differentiated and something that can go to 0 or something that will go back to itself easily. We'll talk about that later, but in this case, we just have this x function, and this can easily go to 0 or some constant quickly. So we're going to have u equal to x. Take the derivative of that. Derivative of x is 1 dx. And then we have derivative, we're going to have to find v. So we're going to use e to the x dx. And then we're going to have to integrate this, which is actually just going to be e to the x. And we have this formula, so we have integral of u dv is equal to uv minus integral of v du. So we'll actually, this is equivalent. So u times v, so x e to the x, minus the integral of v, which is e to the x, and then we have du. du is equal to 1 dx, so just dx. So then we have x e to the x minus integral of e to the x dx, which equals x e to the x minus e to the x, because integral of e to the x is e to the x. We'll simplify this a little bit further. We'll have e to the x times the quantity of x minus 1. Okay. We'll go on to the second problem here. So we have e to the 2x sine x. So if we look at what we're going to set u equal to and v, we notice that nothing really goes to 0 if we take the derivative of that. So the goal is to get something that is the same, so then we can move it over to the other side. So in this case, we're going to take e to the 2x as u. We take the derivative of that, we're going to have 2e to the 2x, and then we're going to set this equal to sine x dx, and then, oops, probably should include the dx there. And then integral of sine is going to be negative cosine x. So we're going to use that formula again that's up top here. u dv is equal to uv minus integral v du. So we're going to have e to the 2x, so we're going to just put the negative out front. E to the 2x cosine x minus the integral of v du, so negative cosine x, and then 2e to the 2x dx. We'll take care of these negative signs by just making them both positive. And we notice that this isn't easily integrated, so we're going to actually have to use the integration by parts again, so the second iteration of this. So I'll write this off to the side here. Cosine x, and we'll actually take the constant out. 2e to the 2x dx. And we're going to set u equal to 2e to the 2x again, which will get us 4e to the 2x. And then we have v dv, so dv is actually going to be cosine x dx. And integral of cosine x is going to be sine x. And then we're going to set that equal to 2 times the quantity. Oops, we actually took the 2 out. I apologize about that. So we're going to have this, well, we'll just solve it this way. Sorry about that. So we're going to have uv, so 2e to the 2x times sine x minus integral of v, which is sine x, du, 4e to the 2x dx. Now we'll notice that this portion is actually the same as this, except we have this constant 4 out. So we're just going to rewrite this because we have this part, and then this integral is actually the same as this. So I'm going to write this out, e to the 2x sine x dx is actually equal to negative e to the 2x cosine x plus 2e to the 2x sine x minus the integral. We'll actually take the constant out there, so 4 times the integral of sine x e to the 2x dx. So what we have is we have these two the same, so we're going to add 4 of the integral over, so we're actually going to have 5 times the integral of e to the 2x sine x dx, which is equal to negative e to the 2x cosine x plus 2e to the 2x sine x, and then we can just divide everything by 5. Sine x dx is going to be equal to 1/5, and we'll switch the signs just so it looks a little cleaner, 2e to the 2x sine x minus e to the 2x cosine x. And that is our solution. Now finally, there's one more method that we can actually solve these integration by parts easily. It's called tabular method. So when we have multiple iterations of this, and we can get up to 5, 6, 7, it gets kind of messy if you're doing this all by this method, and it's kind of time consuming. You can do another method that's much easier. So tabular method, we will have this table. So we'll start off, we have this integral x squared cosine x, oops, can't forget the dx, and we're going to try to solve this. So the way we do this is we want to take the derivative of something that goes to 0 eventually, and this polynomial x squared will go to 0 after a while. So we're going to have this d for derivative, so we're going to have x squared, derivative is 2x, 2, and then 0. The integral, we're going to take this part, so we're going to have cosine x. We're going to leave out the dx for now. So the integral of cosine is sine x, goes to negative cosine x, and then negative sine x. Now we start off, we're going to put positive, negative, positive, negative. And then we're going to go down this line. We're going to go diagonal. So we're going to write this out. X squared cosine x dx is going to be equal positive x squared sine x minus 2x negative cosine x. The two negatives cancel. So we're going to have plus 2x cosine x. And then we've got plus 2 times negative sine x. So we have minus 2 sine x. So this table just helps us get through the u's and v's a lot quicker. If you have multiple iterations of it, use this. You will use this thoroughly in differential equations. So get really good at this, as it will save time on exams.